Have you ever wondered how pilots navigate through the skies, especially in poor visibility conditions? Well, one of the key tools they use is the VOR, or Very High Frequency Omnidirectional Radio Range. The VOR is a high-frequency radio navigation system widely used in instrument flight. It's like an invisible road map in the sky, guiding pilots to their destinations. Compared to other navigation systems like the ADF or NDB, the VOR has some clear advantages. It's less susceptible to electrical and atmospheric interference, including storms. Plus, it eliminates the limitations of night effects, as its VHF signals are line of sight and aren't reflected by the ionosphere. This makes the VOR a reliable navigation tool in any weather conditions, day or night. Whether it's for orientation, tracking a route, or even making instrument approaches for landing, the VOR is an invaluable part of aviation. So that's the basic importance of VOR in aviation, but how does it actually work? The technicalities of VOR might seem complex at first, but let's break it down to understand how it operates. VOR stands for Very High Frequency Omnidirectional Radio Range. It operates within a specific VHF frequency range between 108.00 and 117.95 MHz, which is a lower frequency band than that used for VHF communications. Now, each VOR ground station emits two types of VHF radio signals. First, we have the reference phase. This is an omnidirectional signal, meaning it is the same in all directions. Second, we have the variable phase. This signal rotates uniformly at a rate of 1,800 revolutions per minute, with its phase varying at a constant rate through all 360 degrees. The antenna of a VOR receiver on an aircraft picks up these signals. It then measures the difference in phase between them. That's the difference between their wave peaks. This phase difference depends on the bearing of the aircraft from the VOR ground station. Now, you might be wondering how we can determine the distance from the VOR station. This is where distance measuring equipment, or DME, comes into play. Many VORs are paired with a DME, so when you select the VOR on the VHF nav set in the cockpit, it also selects the DME. This provides both bearing and distance information, giving pilots a precise position fix. In a nutshell, the VOR system uses the interplay of two signals, the reference phase and variable phase, and the measurement of their phase difference, to offer directional guidance. When coupled with DME, it also provides distance information. Just like that, VOR helps pilots to accurately determine their position and navigate their way to their destination. But let's summarize what we've learned. So we've covered a lot about VOR today. Let's quickly recap the key points. VOR, or Very High Frequency Omnidirectional Radio Range, is a high-frequency radio navigation system commonly used in instrument flying. Each terrestrial VOR station emits on a specific VHF frequency between 108.00 and 117.95 MHz. This frequency band is lower than the one used for VHF communications, requiring a separate VHF nav radio for navigation purposes. When VOR was introduced, it offered an immediate upgrade from existing means, such as the ADF-NDB combination, most of which operated in lower frequency bands and had significant limitations. The main advantages of VOR include reduced sensitivity to electrical and atmospheric interferences and the elimination of night effect, as VHF signals are transmission lines and are not reflected by the ionosphere. The safety and accuracy of VOR signals allow for its confident use in any weather conditions, day or night, for purposes such as orientation and position fixing, moving towards or away from a VOR ground station, holding for delay or maneuvering actions, and instrumental approaches for landing. Many VORs are coupled with a DME, or distance measuring equipment, which provides the distance from the station in nautical miles. Selecting the VOR on the VHF nav set in the cockpit also selects the DME, providing both direction and distance information. The terrestrial VOR station transmits two VHF radio signals, a reference phase, which is omnidirectional, and a variable phase, which rotates uniformly at a rate of 1,800 revolutions per minute. The antenna of a VOR receiver on an aircraft receives these signals, and their phase difference is measured. This difference depends on the aircraft's bearing from the ground station, allowing the VOR to determine the aircraft's magnetic bearing from the VOR ground station. So, the next time you're in a plane, remember that VOR might just be the invisible guide helping your pilot navigate the skies. Thanks for tuning in, and don't forget to subscribe for more insights into the world of aviation.